This is Lesson 1 of Unit 9, Parametric Equations and Plane Curves. So this is going to be a review of parametric equations, and from there we're going to build on that to talk about how calculus is related to parametric equations and eventually polar coordinates. So in pre-calculus, we talked about continuous functions and we created planar curves. Now, we usually used x and y as our variables, but we may need to know when an object is at a given location, and that's when we introduce the third variable called a parameter that we usually use t because most of the time it's signifying some time. So we're going to reintroduce here what a parametrically defined function is. So if x and y coordinates of a point on a graph are given as functions of f and g of a third variable t, then what we do is we define x in terms of that parameter t, so we have an f of t, and the same for y, we determine that in terms of t as well. So they are our parametric equations, and t, as I've said, is a parameter. So we not only can draw the curve, but we can show how the curve is drawn by seeing how a particle would move over time. So our curve C that we're going to draw, our parametric curve, is going to be a result of two functions, f of t and g of t. And that is called the parametrization of the curve, and each of those is a parametrization and it's parameterized. Okay. So here we go. So one thing you want to be able to do is to plot points, sketch a parametric curve, and be able to see how it moves along the grid. So what you do is you take your t values, you substitute them into your x of t and your y of t, and then when you plot your points, you're going to plot them on an xy curve. So you're plotting the xy points, not necessarily the t. So filling out this table real quick, I'm literally going to do, put -2 in for t in the x equation, and I'll get 4. And when I substitute -2 in the t cubed minus 3t, I will get -2. And I'm going to do that for all these points. So I'm just going to go ahead and fill out the table, really. Okay, so there's the table filled out. Again, I got those points by just substituting these given t values into these two equations and getting the points. Now I want to plot them in order because remember, I realize we have negative time here, but we want to see how the curve is sketched out as we move to larger and larger t's. So we're going to plot our points in order. So the first point is 4, -2. And then we go to 3, 0. And then from there we go to 1, 2. And then to 0, 0. Then to 1, -2. Back to 3, 0. And then to 4, 2. So when we draw this, it should look like this. And when we talk about marking the orientation, we want to think about the order in which the points were created as t got bigger and how we plotted them as such, like that. So that shows the orientation of the curve. Okay, example 2. We are going to change the following to rectangular form by eliminating the parameter. So we want to write y as a function of x and eliminate t altogether. So what you want to do is take the equation that seems to be easier to solve for t and solve it for t, and then we're going to substitute into the other equation. So I'm going to take the x equation. I'm going to cross multiply here. So I'm going to have the square root of t plus 1 equals 1 over x. I'm going to square both sides. T plus 1 equals 1 over x squared, and then I'm going to solve for t, so I have t equals 1 over x squared minus 1, and I'm going to create a common denominator and make one fraction because it'll be easier to substitute into y. So this becomes 1 minus x squared over x squared. Now I'm going to take that and I am going to substitute it into my y equation. So I'm going to put in 1 minus x squared over x squared, and in the denominator I'm going to put 1 minus x squared over x squared plus 1. Now I'm just going to multiply top and bottom by x squared to simplify. That should have a squared. So I get that y equals 1 minus x squared in the numerator, and the denominator is just going to be 1, because the x squared will cancel, so I'll have 1 minus x squared plus x squared, because remember I have to distribute that. And then the x squareds will cancel, so y becomes 1 minus x squared. So there's part 1 of my equation. Now I'm asked to graph the equation, so I'm going to make a little table here. So I have x, I have y, and I'm just going to plot some points. So -1, 0, 1, and 2. I'm just using what I have there on the grid. That's how I pick my x values. So then when x is -1, y is 0, and then we have 1, and then we have 0 again, and then we have -3. So our curve is going to look like this. So we're at -1, 0, and then we're at 0, 1, and then we're at 1, 0, and then we're at 2, -3. And this should look like a concave down parabola from the looks of the equation, which it does. So we're going to have a curve that looks like this, and will of course continue. So here's our orientation of our curve, like that. Okay, sometimes you can use some trigonometry to eliminate it, and by that using some of our Pythagorean identities. So when you have cosine and sine that you can get by itself in the same equation, a good thing to do is to use a Pythagorean identity. You want x squared plus y squared, so that will equal 1. And in this case, you just want to be careful because t is not the parameter. The parameter in this is theta, because we just want a function that is x and y and no theta, no other third variable. So if I solve x for cosine theta is going to equal x over 4. Now if I square both sides, I get cosine squared theta is x squared over 16. And then if I do the same thing with the y, so I have sine theta equals y over 3. So sine squared theta is going to equal y squared over 9. So now I know that if I add cosine squared theta plus sine squared theta, I get 1, and that has to be equal to x squared over 16 plus y squared over 9. And that, hopefully you recall that that is an ellipse, and it is centered at 0, 0. And A is going to be 4. That's 1. On the x-axis, that's how we're going to be stretched out, and B is 3 on the y. Sorry there, I lost my train of thought for a second. So we have our center at 0, 0. So we're going to be 4 units from that center on the x-axis and 3 units on the y-axis. So there's our graph. Okay, so sometimes we have to find a parametric equation. So if you want position, direction, speed, it's easiest to make a parametric equation, because we've been talking a lot in this class about x traveling in one direction, the horizontal direction. So it'd be really great if we just had an x of t equation separate from a y and x equation. So we have the equation y equals 2 minus x squared, and we're given a parameter in each part. And we want to create the parametric equations that go with that. So we already have one. X equals t is our first one. So we are going to, in our y equation in part A, we're going to replace we're going to replace x with t. So this is going to become t squared. So our parametric equations are going to be y equals 2 minus t squared and x equals t. Now if you notice, we are using a calculus concept here is the fact that our slope is dy dx. So we want to somehow work our m into our equation. So we're going to do it in this way. We're going to start with y equals 2 minus x squared, and we can find dy dx by taking the derivative. So we get 2 minus 2x, and whoops, I'm not 2 minus 2x, sorry. We just get negative 2x, and so now we can call that m, and then we can solve for x. So now we're going to have our two equations. We're going to have x is going to equal, I guess I don't need the parentheses, x is going to equal m over negative 2. And now y is going to be 2 minus, and now I'm going to take this parameterization and substitute it in for x, negative m over 2 squared. So I get 2 minus m squared over 4. So my answer for part B is going to be x equals negative m over 2, and y is going to equal 2 minus m squared over 4, because m is our parameter in part B. Okay, so now, how do you do a parameterization of a line? So the nicest thing is if you're given one point, it becomes very easy. Your A and your B of that point are going to be the y-intercepts of the individual x and y equations. And then the slope can be thought of, your r and your s comes from the idea, remember your slope normally is rise over run. So that's the s change would be the y change over the r, which would be the x change, because it's change in y over change in x. So if you're doing it in one direction, that s becomes the slope of the linear equation in the y direction, because that's how y changes. And the r becomes the slope of the parameterization of the x equation, because that's how the x changes. Okay, so for the idea of having 2 points, though, now the equation gets a little trickier. So now if you notice, we're going to do c minus a to get the rate of change in the x direction, and we're going to do d minus b to get the rate of change in the y direction. So we're still just focusing on the idea that we're looking how the y's change for the y direction and how the x's change for the x direction. And again, a and excuse me, a and c are going to be our starting value. So there are intercepts for each direction. Okay, so let's do an example with this. So for number 5, we are finding the parametric equations for the line through the point 3, negative 2 with a slope of 4. So we have everything we need here to do this. We're going to use the idea that we have x equals a plus rt, and y equals b plus st. So with p being 3, negative 2, that is our a and our b. So our slope m, remember, is s over r, and we have 4, or 4 over 1, so we can just break it down in that way. So s is going to equal 4, and r is going to equal 1. So we have our equations then. So x is going to be 3 plus t, and y is going to be negative 2 plus 4t, because the only change is going to be in the y direction, because we have 4 over 1. Okay, so number 6 now, we have 2 points. And remember, you don't really have to memorize the equations. You just want to remember that whatever point you're starting from, P, these coordinates are going to be your intercepts, because that's your starting point. And the rate of change for each direction is going to be how far the distance is from the x's and also from the y's. That's going to be how you're going to get your s and your r. So just to write the little formulas down though, x equals a plus t times c minus a. And so we have everything we need to solve this. So x becomes 2 plus t times, and then our c is 4 minus 2. So we can simplify this. So x becomes 2 plus 2t. And then for y, should be d minus b. Okay, now we're going to do the same thing for the y. So our starting y value is at negative 6. And we just have to find how far apart we are from negative 3 to negative 6. So this becomes a plus there. So y becomes negative 6 plus 3t. So here is our answer. Here's our y parameterization, and there's our x parameterization. Okay, so we want to end this section by talking about how to do this in your graphing calculator. So if you have an 84, you want to make sure that you change the mode of your calculator to parametric mode. So I'm going to go under mode, and I'm going to go down to where it says function, and I'm going to change that over to parametric. I'm going to do this first, and then I will show you how to do it on the Inspire next. Okay, so I can quit out of here. Now what we want to do then, if we look at this, is we want to look at a specific graph here, and this is called a cycloid, and we have a hypocycloid here, which means under the wheel, because a cycloid looks like a wheel spinning. That's where the idea behind a spiral graph comes in. So here's our parametric equations, and this is what the graph normally looks like. So we have 5 times the cosine of t plus 3 times cosine of 5t over 3. That's our x equation and our y. And when it traces out, it looks like this. So here's how we're going to do this on the calculator. So let me do it first, our example down here on our 84. Then I'll go back and do the steps on the Inspire. Okay, so we're going to graph this cycloid from 0 to 6 pi, and the window sizes are negative 3 to 20 and negative 3 to 6 on the y scale. So in your calculator, you're going to go under y equals, and you're going to type those in. You'll see that it looks different, that you have an x1 and a y1, and they both have a subscript of t, because that's what that's your independent variable. So when you hit the variable key, a t will come in to play here. And there is our y equation. Now you want to make sure when you're doing these that you change your viewing window for what's given. So when I hit window, I now have a t in here. So they said from 0 to 6 pi. So you want to change, you're going to go from 0, and you can just type in 6 times pi. And you want to make your steps small. 0.1 will work. And our y's, we want to go from -3 to 20. And you can adjust whatever scale you want for this. I'm just going to leave it as 1. And then our x's are from -3 to 6. And now you just hit graph, and you want to take note to how it's traced out as well, because that will help you see what you're supposed to graph. Okay, so there's 6 pi. All right, so then you just have to sketch that on your grid. Okay, and you can do that by hitting trace and just follow along, and just find some nice points that are easy to graph. Like you want to trace up here till you're on the y-axis up here. Just try to get as close as possible here, because it's going to be hard. Remember, you're counting your independent variable is t, so it's not like you can put, oh, let me put x equals 0 in, because it'll actually put t equals 0 in. Okay, so you're going to sketch that on your grid. All right, so then I'm going to do this on the Inspire. Okay, doing this on the Inspire calculator, what you want to do is open a graph page. You want to press menu, and you want to go to number 3 that says graph entry, and you want to choose parametric mode for that. And now you'll see you have x1 of t, y1 of t, and your t step and everything is right here. 6.28 is 2 pi, so we'll change that to 6 pi. And then we're just going to type in our equations here. So we just press T on your keyboard at the bottom. So we'll do 2 minus sine t, and then we'll do 2 minus 2 cosine t. Okay, and then we just have to go down here and change. We can leave our t step alone. We'll just change this to 6 times pi. So we get the same picture. And now what we want to do is hit window and go to, we'll hit menu and then go to 4 window, and we'll do number 1, our window settings. And again, we want to put in from -3 to 20. Oops, sorry. And our y's will be from -3 to 6. And now we can just hit enter and enter again, and there's our curve. Okay, and so when you sketch it on your paper, it'll look like this, and you're good to go. And that's the end of this lesson.